What if we attempted the most audacious experiment in human history, pouring every drop of water on Earth onto the sun? Would we extinguish its fiery inferno and save our planet from global warming? Or would we trigger an unimaginable catastrophe, one that could reshape the very fabric of our solar system? The idea seems almost poetic, our vast ocean sacrificed to quench the celestial fireball that lights our world. But what if, instead of cooling it down, we accidentally created something even more chaotic, something beyond our comprehension? Could the very act of attempting to extinguish the sun set off a chain reaction that alters the balance of our solar system forever? The answer lies in the fundamental nature of the sun, an unfathomably immense nuclear fusion reactor where unimaginable forces are at play. To truly grasp what would happen, we must dive deep into the science of our star, breaking apart the seemingly logical assumption that more water means less fire and confronting the startling reality that our actions could lead to an even more dramatic cosmic spectacle than we ever imagined. At first, it sounds deceptively simple. After all, water puts out fire, so why wouldn't it work on the sun? But here's where things take a mind-bending turn. The sun isn't burning in the way a campfire does. It's an immense nuclear fusion reactor, crushing atoms together with incomprehensible force. Adding water, H2O, a molecule packed with hydrogen and oxygen, could set off an explosive chain reaction beyond anything we've ever witnessed. So, what would really happen? Would the sun dim and cool, or would we unleash an astronomical scale disaster? Let's dive into this thought experiment, peeling back the layers of science, destruction, and the unpredictable consequences of messing with a star. To understand what happens when we add water to the sun, we first need to understand what the sun actually is. Unlike a traditional fire, which requires oxygen to burn, the sun is a massive sphere of mostly hydrogen, about 70%, and helium 28%, with extreme temperatures and pressures enabling nuclear fusion. This process fuses hydrogen atoms into helium, releasing immense energy in the form of heat and light. The sun is about 1.3 million times the volume of Earth, with a surface temperature of approximately 5,600 degrees Celsius (10 degrees Fahrenheit) and a core temperature reaching a mind-blowing 15 million degrees Celsius (27 million degrees Fahrenheit). It produces 3.8 xyd watts of energy every second, enough to power Earth for billions of years. Constantly emitting charged particles in all directions, its environment is so hostile that even the most advanced spacecraft struggle to get close. Now, what happens if we introduce a new element, Earth's entire water supply, into this chaotic system? Would the sun merely absorb the water and keep burning, or would something completely unexpected unfold? Before we dive into throwing oceans at the sun, let's start small. What happens if we send a single glass of water, about 250 milliliters, hurtling toward the sun at high speed? Would it even make it close before being obliterated? As the Parker Solar Probe approaches the sun, the glass of water would begin to evaporate long before reaching the surface. The sun's intense radiation would immediately break apart the water molecules into their basic components, hydrogen and oxygen. These gases, now stripped of their molecular bonds, would be rapidly swept away by the sun's relentless solar wind. The sun, being a nuclear fusion powerhouse, wouldn't even flinch. It wouldn't cool down, sputter, or react in any noticeable way. In essence, sending a mere glass of water to the sun is like tossing a snowflake into a raging inferno. It vanishes instantly, leaving no trace. Now, let's scale up. What if we took an entire lake, say, Lake Superior, which holds about 12,100 cubic kilometers of water, and hurled it at the sun? Getting this water into space is already an impossible task. Even if we had rockets powerful enough to transport such a vast amount of water, the sheer distance, about 150 million kilometers or 93 million miles, would make the journey impractical. But let's assume, for the sake of argument, that we somehow manage to deliver this immense payload. As this massive volume of water gets closer to the sun, it experiences the same fate as the glass of water. Intense radiation splits it into hydrogen and oxygen. However, the hydrogen component is where things get interesting. Hydrogen is the sun's primary fuel. Instead of cooling it down, adding billions of tons of hydrogen would only fuel more nuclear fusion, making the sun even hotter and more active rather than extinguishing it. Now, let's take the ultimate leap. What if we somehow gathered all the water on Earth, all oceans, lakes, rivers, and ice caps, totaling 1.3 billion cubic kilometers, 310 million cubic miles of water, and dumped it into the sun. This is where things take an unexpected turn. By adding such an enormous amount of hydrogen, we might trigger a temporary increase in solar activity, leading to massive solar flares, increased radiation output, and an even hotter sun. The added oxygen would briefly react with the sun's outer layers but wouldn't have a lasting effect. Instead of cooling the sun, we might be accelerating its nuclear reactions, causing it to become more unstable and ejecting even greater amounts of radiation into space. This could lead to catastrophic solar storms that would wreak havoc on Earth's power grids, satellites, and communications systems. Even if we ignore the disastrous consequences, transporting Earth's water to the sun is an engineering impossibility. The strongest water pumps on Earth, like the Nigewi's pumps used for flood control, wouldn't even make a dent in moving such an immense volume. Rockets would be needed, but the number of launches required would be astronomical, likely more than the total number of rockets ever built in human history. The energy required to move water against Earth's gravity, accelerate it through space, and deposit it into the sun would likely exceed the total energy output of our civilization. At the end of the day, pouring Earth's water onto the sun would not save us, it would likely make things worse. Instead of cooling it down, we'd be adding more fuel to the fire, possibly making the sun hotter and more dangerous. The sudden influx of hydrogen could temporarily supercharge nuclear fusion, leading to an increase in solar activity, powerful flares, and heightened radiation that could have devastating consequences for Earth. And even if, by some miracle, this method worked to lower the sun's temperature, Earth would be left completely dry, turning it into an uninhabitable wasteland where life as we know it would cease to exist. Instead of chasing impossible solutions, we need to focus on real, tangible actions that can help our planet. The real way to combat climate change and global warming is through sustainable energy sources, drastic reductions in greenhouse gas emissions, and the adoption of new technologies designed to preserve our planet's delicate balance. We need to invest in solar and wind power, rethink industrial processes, and protect our natural ecosystems. It's up to all of us to take action starting today. Reduce waste, support clean energy initiatives, and push for policies that protect our environment. The fate of our planet isn't in the stars, it's in our hands,